Voyager 1 has NASA experts in a state of excitement. The people in charge had actually only instructed the cosmic old-timer to turn on its heater. But then the probe did something that absolutely no one had expected, which even fueled concerns that contact would be lost for good. Want to know what unforeseen problem arose in the depths of interstellar space, and how the ancient probe finally managed to phone home with the help of a long-forgotten backup transmitter? Then stay tuned until the end and see for yourself what happened to Voyager 1. When it's cold, it's usually a good idea to turn on the heating. So far, so obvious. However, things get a lot more complicated when the temperatures need to be raised not in our living rooms, but at a distance of almost 25 billion kilometers. The fact that Voyager 1 has now reached interstellar space since its launch on September 5, 1977, is by no means the only problem facing NASA experts. After all, the ancient probe is now almost regularly drawing attention to itself with technical glitches that repeatedly cause headaches for those responsible. And so it came to pass that what should have been a routine command once again led to Voyager 1 making unpleasant headlines a few months ago. What happened? Basically, NASA experts had instructed the probe to activate one of its heaters on October 16, 2024. But just under 2 days later, the unexpected news came that the Deep Space Network could no longer detect Voyager 1 signal. The fact that the researchers had to wait so long before this unpleasant realization dawned on them is again due to the immense distance involved. It takes 23 hours for a message to travel the gigantic distance of almost 25 billion kilometers. It therefore takes just as long for Voyager's response to reach Earth, assuming, of course, that it arrives at all. To understand why this was not the case at the time, we must first bear in mind that Voyager 1 is equipped with an onboard error protection system that responds independently to problems. This is the case, for example, when the probe's power supply is overloaded and the fault protection system deactivates systems that are not essential for the operation of the spacecraft in order to save energy. Unfortunately, the heating command also triggered the fault protection system, which was all the more confusing given that Voyager 1 actually had enough energy to activate the component. X-band transmission trouble. For better understanding, it should be briefly mentioned that the probe usually communicates with Earth via a so-called X-band radio transmitter, which is named after its specific frequency, normally between 8 and 12 gigahertz. This enables the transmitter to transmit data from interstellar space to Earth at relatively high speeds. However, after contact was lost, experts correctly assumed that the error protection system had reduced the rate at which the transmitter sent back data. From a pure energy-saving perspective, this makes perfect sense, as this mode consumes less power. Unfortunately, however, and this is the crucial point, it also changes the X-band signal that the Deep Space Network has to search for. To everyone's relief, NASA's engineers managed to track down the signal in question on October 18th. Which, however, did not mean that the technical complications were over. How Voyager 1 phoned home using a backup transmitter over 40 years old. Although the probe appeared to be in a stable condition, the next problem quickly followed, and communication broke down completely the next day. Those responsible estimated that the fault protection system was also responsible this time. It is likely to have been triggered incorrectly again, switching off the X-band transmitter and switching to the S-band instead. However, the fact that it was reactivated was surprising, to say the least. Although the S-band consumes less energy than the X-band, Voyager 1 had not used it to exchange messages with Earth since 1981, and that was no coincidence. Despite all its power-saving advantages, the S-band uses a lower frequency than the X-band transmitter, which means that less data reaches us and transmission takes longer. In fact, the S-band transmitter was only ever intended as a backup solution, as it was known in advance of the mission that cosmic radiation could affect electronic components. With this knowledge in mind, and given the enormous distance involved, NASA experts were initially not even sure whether they would be able to detect the S-band signal at all, or whether they had now lost contact with Voyager 1 for good. Fortunately, however, they were able to find it, and were then faced with a decision of what steps to take next. Given the history of error protection, they felt that simply reactivating the X-band was too risky. This should only be done once the cause of the system activation had been clearly identified. However, past experience has shown that such error analysis can sometimes take several weeks or even months. A temporary lifeline. So were the experts doomed to simply abandon contact with Voyager 1 in the meantime? Fortunately, that was not the case because, as mentioned above, there was still the S-band transmitter. On October 22nd, NASA sent a command to test whether it was still working as intended. And lo and behold, 2 days later, the welcome response came back that a stable connection had been established. And so it came to pass that NASA's backup transmitter, which had not been used for over 40 years, played a key role in getting us out of a mess and maintaining contact with humanity's most remote outpost. What's the situation now? Is Voyager 1 still transmitting via this emergency solution? No. From the transmitter's point of view, everything is back to normal. NASA announced in a press release on November 26, 2024, that the radio problems had been successfully resolved and that Voyager 1 was once again using its primary X-band transmitter. How the life of the Voyager probes is being extended. However, the whole truth about Voyager is that nearly 50 years in space have taken their toll on the identical twin probes, and that we must slowly but surely come to terms with the fact that even the longest-running success story in space travel will come to an end at some point. When Voyager 1 and 2 plunged into space in 1977, no one could have guessed that this was the start of the longest-running success story in space travel. After all, the probes had originally been sent out to explore the outer planets of the solar system, which were still largely unexplored at the time. The time frame for the Voyager mission was therefore set at just 5 years. But today we are smarter and know that the spacecraft have exceeded this originally predicted lifespan by almost 10 times, and have ventured deeper into space than any other man-made object. And yet this immediately raises the fundamental question of how this is even possible. In other words, how can probes that are based on 1970s technology still be flying through space unperturbed and continuing to provide us with unique data from interstellar space? Let's not forget, the onboard computer of the Voyager probes does not even have a millionth of the storage capacity of a modern cell phone. The transmission rates are 38,000 times lower than a standard mobile phone connection, and the data collected by the scientific instruments is still stored on magnetic tapes. And although the Voyager probes are undoubtedly a marvel of robust technology, the plutonium spheres in their thermoelectric generators now only deliver about half their original power. To prevent these cosmic old-timers from running out of juice, NASA has been following a strict power-saving plan for some time now. In fact, all non-essential systems were shut down years ago, followed by a backup system in 2023 and a plasma sensor on Voyager 2 in 2024. However, as the energy supply continues to dwindle despite these measures, with 4 watts of power lost each year, further cuts were recently necessary to maintain the operation of the twin probes. More specifically, on February 25th, this affected the cosmic ray subsystem on board Voyager 1. This instrument consists of 3 telescopes that capture the energy and flux density of high-energy protons from the Milky Way and the Sun, and whose data revealed to experts in 2012 that Voyager 1 had broken through the boundaries of our home system. On March 24th, the sensor for charged low-energy particles was switched off on board Voyager 2. This sensor primarily measures the less energetic particles of cosmic radiation and the solar and galactic magnetosphere. As a result, the veteran probes now have only 3 of their original 10 instruments: Voyager 1 magnetometer, plasma wave subsystem, and the low-energy charged particle sensor, scheduled for deactivation in 2026. Voyager 2 magnetic field sensor, plasma wave instrument, and cosmic radiation subsystem, to be shut down within 2 years. NASA says that the power savings should allow the Voyager probes to remain active until the 2030s. And every bit of additional data that experts can glean until then is a valuable bonus for space exploration. And now, here's something about pipes that you definitely didn't know. The fuel pipes that align Voyager 1's main antenna are now so clogged that they are less than half the diameter of a human hair. Have you clicked the subscribe button yet? Join our community now and never miss another video from us again. We'll see you soon.